Good morning to all. In this time, we are going to see about the antenna pattern characteristics. It is nothing but the radiation pattern characteristics of an antenna. We know that the radiation is the term which is used to represent the electromagnetic radiation or the reception as in the form of wave by the antenna. So, if it is used in the transmitter side, it is used to radiate the electromagnetic wave. I mean, if it is used in the receiver side, it is used to capture the electromagnetic wave. So, the emission or the radiation of electromagnetic wave is the primary duty of antenna, which can be graphically represented in terms of the radiation pattern. So, the graphical representation or the sketch which is drawn to represent the radiation property of an antenna is called as radiation pattern. So, we can understand that the function and the directivity of an antenna is depending upon the radiation pattern only. The power when radiated from the antenna has been spread over in and around its surrounding region, which can be called as the near and far field region, as we have seen in the previous class line. So, graphically, the radiation can be plotted as a function of angular position or the radial distance. So, the radiation pattern or the pattern characteristics means it is a mathematical function of radiation property of an antenna, which is represented in spherical coordinate, like it is represented as E theta comma phi and H theta comma phi. So, we know that the spherical coordinates is R theta comma and phi. So, here E theta comma phi represent the electric field radiation characteristics and H theta comma phi represent the magnetic field radiation characteristics. So, this is a pictorial representation of the radiation pattern of an dipole antenna which is situated here, and the directions in each and the arrow in each and every line of radiation, it represents the direction of radiation. So, the radiation pattern is a graphical and diagrammatic representation of distribution of radiation energy in terms of the direction. That is, the direction as the function, because we have the EM wave radiation in this space only. So, the radiation pattern can be drawn in 3D or 2D. So, here this is a structure that represents the 3D radiation pattern of a ideal antenna. It can be represented in spherical coordinate by using 3, that is R theta comma phi. So, here assuming its origin at the center of the spherical coordinate. So, we have assumed that the antenna is placed at the origin. So, if we want to convert the 3D radiation pattern into 2D, what we have to do? We have to cut the 3D radiation pattern either in horizontal plane or with respect to the vertical plane. So, if we cut the 3D pattern in horizontal plane, we will be having the horizontal pattern, or it can be cut with respect to the vertical plane, which will give the vertical pattern respectively. So, this is a diagrammatic representation of the side view and top view of the radiation pattern in 3D. Here, this is the E plane radiation pattern and this is the H plane radiation pattern. So, here this is the ideal shape for the ideal or the better performed radiation pattern antenna. So, here you will be having normally it is represented in the form of the numerical letter 8, right? So, the ideal 8 characteristics, okay, this is in the horizontal. So, the antenna is oriented with respect to the horizontal plane. So, here if you located the antenna in the vertical plane, if it is an ideal antenna, you will be having 8 in the vertical position also. And here this is the top view which represents the H plane radiation pattern. Here it is similar to the isotropic radiation antenna, right, where we have the equal radiation in all the 360 degrees, start from 0 to 360. So, this circle in the H plane represents the omnidirectional radiation pattern. This is the bidirectional radiation pattern, and this is the different antennas radiation pattern, which can able to help to understand about the different parts of the radiation pattern, right? So, the radiation pattern can be a field pattern or it can be a power pattern. It can be drawn with respect to the E field strength and H field strength. If it is drawn in terms of E field strength, then it is called as E field pattern. If the H field strength is drawn with respect to the direction as a function, then it is called as magnetic field pattern, that is H field pattern. Or it can be drawn in terms of power, then it is called as the power pattern. So, the field pattern is plotted plotted as a function of electric or the magnetic fields. They are plotted in the logarithmic scale, and the power pattern are plotted as a function of square of the magnitude of electric and magnetic field, and they can be plotted in the logarithmic scale by using the dB scale version. And this is the different types of the radiation pattern antenna. Here the major three different types of the radiation pattern it is shown here, and this is the major loop where we have the maximum field radiation in the particular direction. And when compared to this pattern, this radiation pattern has the major loop along with some other minor lobes also, where here when compared to these two, in this radiation pattern the major lobe strength has been diverted or diluted in other directions also, which will give the higher strength in the additional minor lobes also. So there are three patterns in the antenna radiation. There are three parts in the antenna radiation pattern, that is a main lobe and side lobe and back lobe. And side lobe and back lobe combinedly called as minor lobe. There are two major parts. One is the main lobe and the other one is minor lobe. And minor lobe itself can be classified into two, that is side lobe and back lobe. So here what is the meaning for? Here this is called as the main lobe or the major lobe, where we have the maximum radiation from the antenna in a desired particular direction. And these are all called as, these side lobes are called as minor lobes, right? So these collectively called as major lobe. Again, this major lobe can be classified into two categories. So here whatever the lobes we have in two sides of the major lobe, which are all called as these side lobes. So these four and these four are collectively called as side lobe. And whatever the lobe we have just behind the major lobe or the opposite direction of the major lobe, that is called as the back lobe, right? So here the strength of the side lobe and the back lobe is very negligible when compared to this diagram, where here in the major lobes along with the major lobes, in minor lobes also the EM field has been scattered. Thereby we have the strength of the major lobe is less when compared to these two radiation pattern. So the parts of the antenna radiation pattern, it is major and minor. Major lobe it is also called as main lobe or major lobe, where we have the maximum radiation in a particular direction from the desired antenna. And the other parts are the side lobe and the back lobe, and side lobe and back lobe collectively called as the minor lobe. So this is the another pictorial representation to represent the parts of the antenna radiation pattern. So this is the main lobe, which is represented in gray color, and whatever the lobes which is highlighted in blue color, those are all called as the side lobe. And whatever the lobe that is represented as slight gray color, which is just opposite to that of the main lobe, it is called as the back lobe. And this is also the similar direction, where we have the major lobe it represented by red, and the back lobe it represented by blue, and side lobes, 6 number of side lobes we have, it is represented by ash color. And these are the different types of radiation pattern, like omnidirectional radiation pattern, pencil beam radiation pattern, fan beam radiation pattern, shaped beam radiation pattern, and isotropic. You know already that is isotropic antenna, it is usually radiated equally in all the direction. So here omnidirectional antenna means it is nothing but the non-directional antenna, where the remaining patterns are called as directional antenna beam. So here the omnidirectional antenna pattern means if it is drawn in terms of 3D, it is usually having the donut shape, right? It is usually having the donut shape in 3D dimension. And if it is drawn in 2D, here the H plane will give the simple circle which represent the equal radiation in all 360°, and the E plane pattern will have the shape in the figure of 8 pattern. That is the meaning for the different types of antenna. So this is a picture representation for different types of radiation pattern, like this is the fan beam, this is pencil beam, and this is vertical plane pattern and horizontal plane pattern, and this is the E plane pattern or the vertical pattern, where we have the 2D radiation pattern in the shape of 8. And this is the H plane radiation pattern in 2D, which is having a simple circle but represent the equal radiation in all the 360°. And this is the 3D radiation pattern, which is similar to the donut shape. And here this is all about the radiation pattern. So as concluded, the radiation pattern, it represents the graphical representation of field radiated by the antenna. It can be drawn in 3D or 2D depending upon the requirement. Thank you.